Shall we start now?
Let us start, sir.
Sorry, sir?
Yes, sir, we can start, sir.
Okay. So, good afternoon to all of you once again. We are continuing with whatever we are continuing with whatever we were discussing yesterday. So yesterday we tried to introduce the basics of Sage mathematics and how to use certain basic functions, certain concepts like lists, tuples, and one more concept is actually left in SageMath, which is very important to us for the mathematics community people. That is known as sets. Set is an important concept for us because it is the most important concept basically for any mathematician, because we start all these things from sets and we build functions and we proceed like that. So the basic tools that we require in any mathematics computation is of course sets as well as functions. List is something related to programming very much, and set is not like that. Set is actually a mathematical concept. So let us see how to define a set. Okay, how to define a set and what are the possible operations on sets. And as we can expect that most of the natural operations that we usually perform on sets is very much possible in SageMath also. Let me share my screen. Okay. You are able to see the screen, I guess.
Yes, sir.
Right. So this is the Jupyter screen that we introduced yesterday. Let me start a new SageMath worksheet even here. Remember that yesterday itself we have created one worksheet, and I think the name of the worksheet that we gave was the date and CU SageMath workshop, something like that. 01209. I'm giving exactly the same name, SageMath CU. Some name, whatever you prefer. Even if you do not give any name, what will happen is that it will be saved under the name untitled. Okay. So in SageMath Set, we usually define using the symbol, using the command set in bracket. We give a list 1, 2, 3, say. Okay. So this is how we define a set. Now we can define b equal to, say again, set. Remember that I have used, if you have noticed that capital S I have used instead of small s. In fact, small s also will work, but there is a slight difference between these two commands. Starting with small s, lowercase e, lowercase t, and starting with uppercase s and everything else small case, lowercase, there are some fundamental differences. This set, starting with capital S, is actually a SageMath object, whereas small s, small e, small t is a Python object. Okay, SageMath object set is a little bit more featureful compared to the Python object. So we will be always using this set starting with capital S. 2, 3, 6, say something like that, or 6.5, 6.7. These two are two sets. And if you want to actually see what type of an object that we have defined is, if you have some doubt in your mind, you can simply use the command type, print type of A. Okay, if you print type of A, what will happen is SageMath will tell you that what type of object you have actually defined. I am pressing shift enter so that remember that if I am pressing on the run button, or if I am pressing the shift enter, the commands will be executed one by one and a new input cell will be opened. But instead of that, if I am pressing control enter, the commands will be executed but no new input cell will be opened. That's the difference between shift enter and control enter. And also, as yesterday, I will be sharing this code in the Google Sheet, the link to which I have just now shared in the chat box. I'm going to update that Google Sheet now with these commands. So you might have already seen that Google Sheet link. Oh, I have not posted that, sorry. I just pasted it there. Okay. The Google document link is here where you can find all the commands that I am typing. I'll be copying and pasting everything here so that you also can try all these things in the Sage Cell server if you prefer. Sage Cell, it's here. Sage Cell. You can copy and paste whatever I am typing from the Google document to this particular document and see as this, see, you can click on evaluate. So it will be evaluated. You can try like this. Okay, see the reply. It says that class Sage sets, set object, etc. And you can understand that this is something belonging to the class called set. We need not worry about the technicalities in the technical terms used there. Just understand that this is something called set. Okay, the usual mathematical set. That's it. Okay, we define two sets. Now, what are the things that we can do with these sets? So, we can do fundamentally what are the whatever possible operations we usually perform on sets, we can perform even here. First one, let me define another set. D equal to set. Remember that I am defining. I am initially defining a list. This is actually a list. List 1, 2, 3. Then I am converting that list to a set. That's what I am doing. I am not defining set directly. Instead of that, I am defining a set first of all, and after that, I am converting that list into a set. This is how we do things in SageMath. Okay, another one. Just take 1, 2. Now I am going to start asking questions. D. Let us just ask: is this a subset of? A? Print. D is subset A. That's a question. So what is the answer we expect? This is set 1, 2, right? And A is 1, 2, 3. So the answer we expect is actually yes, this is a subset. Oh, sorry, what is a mistake? What mistake I did? I typed some extra S. There are several S's. Is subset. Yeah. So instead of saying yes, SageMath is saying true. So Google Sheet is now updated once again. SageMath simply says that yes. Okay, not yes, true. Now let us try with something else. Maybe we will change this to something else. Remember one thing, whenever you are typing things in the Sage Cell server, you need to type inside the same cell itself, because you cannot get more than one cell inside Sage Cell server. You have to continue with one cell itself. There is no other way. So I am copying and pasting. I am trying with E. What should I try? 2, 4. Is E a subset of A? The answer I expect is false, and in fact the answer is false. We can ask the reverse question also. The reverse question to subset is that it is superset. We can ask the reverse question. Here itself I will ask. Print A is superset. Is superset E. The answer is again false. Okay, I will ask about D. Is A superset of D? The answer is yes. Okay, now let me try once again. Okay, copy and paste. I am updating Google Sheet almost instantaneously. Just to go there and check without much delay. Okay, now let us try with something like intersection. Intersection can be done in two ways. There are two types of intersection commands. Print A and B. I guess that should work. A and B. So that is displayed as set to 3. Okay. And now if you try to display, if you try to just type A, what will happen? It is displayed in this way. So can we define set using this symbol? F equal to. Can we do this? And what is this F? What is this F? This is of class set. So there is a slight difference between these two things. Have you observed? There is a slight difference between these two things. This is something, a longer description is there, right? Class, Sage, sets, set object, etc., etc. But here you have somewhat a shorter description if you are defining like this. Okay, this set is not exactly the same as the set defined here. I am not going to the technicalities right now. I'll try to explain it later. But the set defined using this set notation and set defined using this smallest, the capital S ET set notation, these two are different things in Sage. Okay, this one is much more superior. This one is much more superior compared to this one. Okay, so we will be always using that capital S ET notation. Okay, now one more thing. So we have taken A intersection B, right? A intersection B is appearing like this. Now let us take instead of that A dot intersection. Okay, we try with this. What mistake I did? Intersection B. Okay, I have probably defined it using, no, that should have actually worked. Why is not working? Just 1 second, let me just see, have I done something wrong?
Intersection is, please check spelling of intersection.
Spelling is wrong. Okay, let me just see. I am unable to find where it is. Sorry, thank you. My eyes are actually deceiving me these days. Is it correct now? But even that intersection, A dot intersection is also, we are getting it as a usual set, right? It is not actually what you call the other type of set. If you want to convert it to the Sage set, you need to again use what you call that SCT command. Once again you may have to use. Okay, doesn't matter because now what is the other operation that we can try? Union, let us try. Okay, let me just copy and paste this. Intersection is here in the Google document. A intersection B is here. Let us try with the union now. Print A dot union B. We will try to print some description also. A intersection B. This is one description, so that also we will be able to see. Otherwise, it will be confusing sometimes to understand that what exactly we have done. So union is here. A union B. A union B. A intersection B. Okay, one extra parenthesis appearing here. A union B is this and A intersection B is this. So these two are two operations. Now let us see. Let us try some more operations. Let us try A or B. That also should work. Print instead of that A or B, vertical line, not slanted line. A or B. Instead of A and B, we are using A or B here. Exactly the same result. For A or B, let's try to find A minus B. Print, we copy and paste. A minus B, just use A minus B. A minus B is just 1 because from A remove all the elements in B which are 2 and 3, that's removed. Now one more. How do we call that? Symmetric difference, right? How do we not? Tilde, I think that's a symbol that we usually use. A symmetric difference B. What did we get? A symmetric difference B, we are getting it as 1 and 6.7. Why is it like that? Yeah, 1 and 6.7 are the elements which are not appearing in, which are appearing in exactly one of these sets. Okay, we update the Google Sheet with this. Update. You may try this. Okay, so now there are several other things also we can try. One is that C equal to, let us try to create a set using some list. Suppose that we create all the even numbers from 1 to 100, 2, 4, etc. 100, set of all even numbers. Says this. Okay, now after that, let us try to ask one more question. Is this finite? Sorry, is finite. Yes, this is finite. Or maybe let me just try to see if this also will work. That is not working. So this is the way. This is something known as a method. Whenever you are typing an object and typing a command after that with open close bracket, that's known as a method. So we are actually applying a method on the C, and that method is known as is finite. That's okay. What is the difference between command and method? Well, I don't think that we should get into that technical, the technical side of that thing. So simply understand that whenever we are typing a command-like structure after this C, after a particular object, after a particular variable, that is usually called as a method. Okay, not a command, not a function. That's it. Is finite is, it's a method. So print is finite. Okay, that's working anyway. Yeah, is finite, the answer is true. Now, okay, let us try to see how will you find the size of C? Will that length command work? Yes, length is working. But instead of length, you can even try the very good command for mathematicians, cardinality, C dot cardinality. Now, okay, let me just update the Google Sheet. Oh, I have copied only one. Okay. So the Google Sheet is updated. So can we remove elements from this set? That also we should try to see. So we have yesterday we have seen we can remove we can remove elements from a list. But can we do exactly the same thing in the case of the set? C dot remove. Let us try. 2 is there. Removed. That creates an error. Set has no attribute removed. Okay, we cannot remove elements like that. But if you want to remove elements from set, what you can actually do is you can convert that into a list. Okay, this is not working. So this causes an error. So instead of that, what you can do is suppose that you convert this into a list. See list C. So whatever is there in C, convert that into a list. Now if you print C, what will happen is 2, 4, 6, 8, etc. Now let us remove. So you dot remove. What do you want to remove? Suppose that we want to remove 2. Print C. Maybe we can convert this into again the set. C equal to set C. Set C. Now it's 4, 6, etc. Right? You can see this. Suppose that we take D to be a singleton set. Print D cardinality. So this is 1 as we expect. So let me just update this. Updating the Google Sheet. Updated the Google Sheet up to here. Okay, now let me just move this to another cell. So mode it here. The cardinality of D is given to be 1. Suppose we do exactly the same operation as before. Convert, remove. Of course, you can instead of doing all these things, you can take the difference also. That's also quite possible. Okay, let us try that way also. D equal to, suppose that we want to remove 10. D equal to D minus 10 or D minus D itself. Why do you want? Oh, okay. The D minus D is quite confusing. You are not actually removing one element, but instead of that, you will be removing the entire thing. Even though we are removing the entire thing, what we actually want is remove one element. D is equal to D minus set 10. So what will happen after that? D is an empty set. So the cardinality is therefore 0. So let us ask if this is empty, and the answer is, sorry, it's a method, so open close bracket. So the answer is true. So is empty. Of course, in this particular scenario, we know exactly that what we are doing, what we are removing. Therefore, there is no need to ask this is empty question. But in the case of certain problems, we will be doing certain things dynamically. So in between, we will be removing certain things from some set. We may not know exactly that what are the things actually removed. We will be removing it based on certain conditions. In that case, we may need to check in between that if that set is empty or not. That's why this is empty command becomes handy. You will see practical problems where this is empty command is going to be useful for us. Okay. Now we can ask, just like in mathematics, we can ask that if one particular element is in, one particular element is in that particular set or not. For example, suppose that, okay, let me just update this. Copying everything, good to Google Sheet. Okay, now what we are trying to do? Okay, let us create one large set. Set of first n. What should I create? Let us take n 100. To be the set of all first list 1 to 100 and 1. Remember that when okay, list, not list like that, range of numbers in 1 to 100. If I want to get the range of numbers in 1 to 100, the range object, the specific thing about the range object is that range AB. Oh, this is not closed. Try. Okay, sorry. The important thing about range object is that range AB is a left open right closed set. Okay, range AB you will be getting something like this. If you issue the command range AB, so from A with a difference of 1 up to B minus 1 you will be getting elements. You will not get B because it is left closed and right out. So if you want to get the list of elements starting from 1 up to 100, you need to put 1, 101. If you specifically want the difference between consecutive elements to be 2, 3, 4 like that, you need to specify that here. If you want the consecutive elements to be with a difference of just 1, that either you can put 1 here or you can altogether ignore that. Okay, both are possible, both are valid. Now, question 5 or 4 in 100, answer. Oh, but we have used only, okay, this in is working in both the set case as well as the list case. If you want to print this n100 itself, that's here. So I have updated the Google Sheet. We will try. There are certain built-in sets also available in SageMath. That is very useful. That is in fact the most interesting thing about SageMath is because there are most of the commonly used sets are available as built-in objects in SageMath. For example, print QQ. This is rational field. So double Q, not just one Q, it's double Q. That's a symbol that we use. Question. Print square root of 2, the very famous question. Is square root of 2 a rational number? False. Great. Is this a real number? True, it took some time. It needs to evaluate. So can you guess that what are the notations for natural numbers then? What is the notation for natural numbers? Can someone guess? CC.
NN?
Sorry? You said an NN, right?
Yes, I think.
Yeah. Most probably yes. Then in NN, true. So -4 in ZZ, true. So these are some standard notations, standard sets. For irrationals, I don't know, we can see. A rational number is usually RR minus Q. That's the only thing. That's the only thing probably. II. Okay, let's try to see what this II is. There is no such thing. So most probably II is nothing but RR minus QQ. So you can probably take that. Let us ask. Square root of 2 in RR minus QQ. So question. What is the answer? What happened to that? Okay, this is not enough. So yeah, there is no such notation for actions. You cannot see, this is not actually set object. If you try, this is a kind of field. Not they are not saying, Sage is not denoting this Q or NN or ZZ as what you call an ordinary set. They are some special constructs. So you cannot simply do like that. Maybe you can try print square root of 2 square in QQ. Maybe this will work. Yeah, that's all. we feel there is no notation like that. These are all standard rings. NN is of course not a ring. NN is it's at most a multiplicatively closed set. Okay, let us see what exactly this NN is. NN is non-negative integer semi-ring. That's it. And its type is lazy import. Okay, some technical side, technical words. I don't really know what exactly meant by all these things are. I'm just using that NN. That's it. It's not very important always to understand what exactly Sage calls this particular set is, as long as it serves a purpose. That's what I feel. Okay, let me just update the Google Sheet with this. Updated. Yeah, one more thing we should probably ask. The cardinality. Print n dot cardinality. Okay, maybe I will update it here. Cardinality says infinity. Maybe NN is finite, it's false, all such standard answers it's giving. Is empty, false. So I have updated the Google Sheet. You may Google document. You may please try. Okay, these are some standard sets that we usually use. So yesterday we were discussing about certain functions and we have already seen the functions, sine function, cosine function. We have seen what are the other things we have not. Yeah, we have not tried logarithm function. So let us come back to the functions. So try to do something else with these functions. You can try to use these functions also. Log. What should I type? 100 to the base 10.
Sir, what is the output of real number?
Output of what, sir?
Real thing? Real number?
Symbol.
No, the cardinality of the real number. Like here, cardinality of natural number is showing infinity. So what is the output of cardinality of real number? Like, do we know that cardinality of natural number is countable and uncountable?
No. Sage cannot distinguish between this countable, uncountable infinities and all.
Okay.
So it will simply say it's infinity. That's it. It's not wrong also, right? So when Sage says that the cardinality of real numbers is infinite, it's not wrong.
Right.
It's not completely right, but it's not wrong. It's something more. But of course, Sage will give you only that to be. There is no countable, uncountable kind of stuff, because countable. The concept of uncountability is really difficult even for human mind. So we cannot expect computer to handle that. So it will simply say everything to be infinite. That's it. Okay, so yeah, I was talking about more functions. This is a logarithm function, and you can easily understand that what exactly I typed is log. The notation is log n to base b. That's what I wrote. Okay. So print. If you want to print too many things, you need to use print. Now log e square to base e, or simply log e square. That's true, because if you do not specify any base, what happens is that it's automatically assumed to be the natural logarithm. Will ln work? Ln, natural logarithm, that's a symbol that we use. Will ln work? Let's see. Yes. For natural logarithm, you can use even ln. Will ln work with the base 10 logarithm and other bases? No, that won't work. So if you want to use other base logarithms, you need to use the log command. If you want to use, you can of course specify, if you are using log to the log and without specifying a base with as the second parameter, it will be automatically assumed to be base e logarithm, natural logarithm. But if you are more comfortable with using the ln symbol, that's also permitted here. Okay, this is not allowed. And what about try with something negative? -1. What is this? This is the complex logarithm. It's giving the complex logarithm. Okay. Okay, you will get complex logarithm. That's it. Because you know that you can extend this logarithm function to complex numbers, right? There, these things make sense, right? The real logarithm does not make sense when you are going to 0, but a complex logarithm makes sense. I have updated the Google Sheet. What about 0? Logarithm of 0. Try with that also. No answer. Probably it's in a kind of surprise that what exactly I am asking for. Still running. No reply. So far. Let me just stop. So if you want to stop something which is not giving, see, you can see one hourglass kind of icon here, which means that SageMath is still executing something. So if you want to stop, interrupt in between, you can either simply click on this stop button. Stop. You will see interrupting kernel here. If you feel that you have done something which has made the SageMath system hang, so stop it. But even after stopping, it's still in the hanging part. Kernel, let us try once again. Interrupt. The interrupt is still not complete. Interrupt. Still it's not out of that. I may have to, now it's stopped. Okay. What is reply here? Yeah, here it is come. So if you actually want to stop that because it has gone into a loop, it is hanging, it is not responding, then probably what you can do is you can try to interrupt the procedure, interrupt the process, or you can try to restart. Restart and clear output means that whatever output is displayed here will be completely removed. If you shut down, then you may have to again start the SageMath system. Even though what the things are visible here, SageMath server is not running in the background. If you shut down the entire system, not shutting down the computer, but shutting down the SageMath system. If you do that, then you may have to close the entire thing. You may have to click on the SageMath icon from your desktop, and you may have to restart. Okay, that you may have to do. In case you stop it, in case you are forced to stop it for some reason. Yeah, there are some other functions also, like the greatest integer function, for example. The greatest integer function is usually, in computer science, greatest integer function is usually denoted using the notation floor. Floor of 3.5, 3.4, it's 3, and floor of minus 3.4, it's minus 4. Just like that, there are seal as well, ceiling. So these are some common functions available. Now the absolute value function is available. Abs 3.4. These are some commonly used functions. Maximum minimum functions is also available. For example, suppose that you define first 100 even as 2, 4, etc. First 200. Okay. Maximum of first 100 even. Maximum. And similarly, there is a minimum function also. Min. Updating the Google document. Done. Now there is one more interest. There are a few other interesting functions which we commonly use in our day-to-day purposes. One is the factorial function, print factorial 4. Okay, I started with single comma, so I should use single apostrophe once again to close it. So factorial is maybe I can use even is. Or the Fibonacci numbers also we can define. Suppose that we want to define the first 10 Fibonacci numbers. Okay, how do we define first 10 Fibonacci numbers? So Fibonacci number you are all familiar with, right? One, 2, 3, 5, 8, etc. Fibonacci numbers. You are all probably familiar with Fibonacci numbers. Fibonacci 1, 2, 3, 4, 1, 1, 2, 3. But instead of that, you can even try it with this way also. 1 to 10, suppose. This is an alternate way. Okay. First 4 Fibonacci. How do we define? Fibonacci n 4 n in. First, not first 4. This is first 10, right? Okay, that doesn't matter. That's just a variable name, but still to be meaningful. Let us try to print it. Sorry, ordinary packet, not this packet. Yeah, see. Updated the Google document just now. So in fact, we can find the ratio of Fibonacci numbers also, because we know that the ratio of n plus 1 Fibonacci number to the nth Fibonacci number, that actually converges. Okay, if you want to see that, that also we can try. So let us try to create the first 100 Fibonacci numbers. We have already seen that. Let us try to prepare the first 100 Fibonacci. How much time does it take? Becoming huge. Okay, first 100 Fibonacci is here. Now, what we are trying to do is trying to find out the ratio. So, how do we do that? Let us try to find let us give this name, Fib ratios. So, Fibonacci n, or these elements are all here already, right? Maybe we can even without that directly, Fibonacci n plus 1 by Fibonacci n plus 1 by n for first n in for n in first 100 will not work, because we have not calculated. So where are they? n plus 1. There are certain issues going to come up because we have used first 100 Fibonacci. Okay, let us try n in. Remember that there are 100 Fibonacci numbers. Okay, but these 100 Fibonacci numbers are labeled as 0 to 99. First Fibonacci number is labeled as Fibonacci as the 0th element in that list. This is the list. So this is the list. We have prepared list. So the first Fibonacci number is actually nothing but the 0th element in that list. So we want first element by 0th element, second element by first element, etc. 100th element by 99th element. So n plus 1 should be 100. So n should be at most 99. So first 100 will not work. Range 0 to 100. 0 to 100 means 0 to 99 only will be taken care of, because I have already told you that range will give you left closed, right open intervals. Let us see what exactly happens here. Oh, a lot of error messages. Rational division by 0, but why is that 0? Where is that 0 appearing? Fibonacci n. What is Fibonacci n? N in range. Okay, sorry. N in instead of that, we need to take elements from here, not from here. Okay, even if you take okay, 1 to 100, this also should actually work. This will actually give you the ratio of 100. Okay, this is enough. Fibonacci n in range 1 to 100. So we are not using this essentially. Okay, we are not using these two. Everything as rational numbers, but we want the numerical approximation. Okay, let us try to do that. Okay, I think those whoever is watching this YouTube thing, what I think is that if you are already registered, most probably what you can do is that you can come inside this Google Meet thing. I have been trying to telecast this through YouTube, but somehow what happens is that sometimes it's getting broken. I don't know why it's like that. Is it because of my network problem or not? Anyway, it's if anyone is watching the YouTube streaming thing, since we have around I think 77, 78 here in this Google Meet session, at least 20 more can join is what I guess. Right, so in case you want to join through the Google Meet thing, I think that's the best option, because there is something that we can always monitor. Okay, so okay, this is not okay. We were discussing about, okay, let me just copy paste all these things if I have not already done that. Copying and pasting. Have I copied and pasted already? Copying and pasting to the I have updated the Google document with this. But remember that there is one more important thing to remember, that under this if you can see that I have given some space. I have not given any space. Automatically whenever I am typing if, after that a condition, and after that a colon, automatically the control is going to 1, 2, 3, 4. 4 spaces are left to the from the left margin, and it is moving towards right. And after that, after if I am typing again, it will be coming here, but to start elif I need to again come back to the left margin. Okay, the left margin is really important. Left margin space is really important. You need to be really careful about that. After that, again there is a colon. This is not semicolon, this is colon. You need to definitely put it, otherwise it will fail. Again under that line, it's again at a spacing of 1, 2, 3, 4. After that it is again else. Okay, this is how it's going on. Okay, so that indentation is really important. This is how we use the if condition. Just like that, we can use this if condition for many other purposes. For example, suppose that we want to filter out a few numbers. Suppose that we want to filter out all the multiples of 5. Suppose. Okay, let us see how to do that. But for that you need a for loop also. I am not going into that part right now. But instead of that, Anything else? Anything else we can try? Some other. Okay, let us try to find. Okay, let me just think about another example that we can try. Yeah, okay, let us try to find one problem that we have previously done in the Python workshop. Exactly the same problem I will try to do here, because I want to demonstrate how to use the for loop. Okay, I want to show you how to use a for loop. Just like this if construct, there is another known as for loop, which we use for repeatedly performing actions. Repeatedly performing actions are really required in certain mathematical computations, especially approximations. For example, suppose that we try to find out approximate root of an equation using Newton's approximation method. So repeated computations are required. We cannot manually do that. We cannot keep on copying, pasting, typing the code again and again. But instead of that, we will use a for loop. Let us try to see how to use a for loop. Okay, and for that, we know that the definition of a leap year hopefully it's clear to everyone. Okay, definition of a leap year. So how do we define leap year? The definition of leap year is that either a year has to be a multiple of 400. Okay, so 2000, 1600, 1200, 1000 is 400 into, no, 1000 is not, 800, 400, etc. are leap years. Okay, so the leap year definition fund. Leap year. Why? Either a multiple of 400, or what is the next definition? What is the next part? If it is not if it's a century, either a multiple of century. If it is not a century, then it must be, it's a multiple of 4. This is the definition. So there are two parts. One is that initially we will check if it's a multiple of 400 or not. If it's a multiple of 400, it's a leap year. Now 100 multiples are all going to be 400s. Then only we will call, if 100 multiple is multiple of 400 also, then only we will call a year to be a leap year. If a century, which is not a multiple of 400, we will not call that to be a leap year. For example, 2100 is not a leap year. 1900 is not a leap year. 1800 is not a leap year. 1700 is not a leap year, but 1600 is a leap year. If you are not very sure about that, you can check the calendar available in your computer desktop or the calendar available in your mobile to see that if 1900, the February consists of 29 days or 28 days. Okay, if you are not convinced about that, you can go there and check. This is the definition of a leap year. So how do we code it using SageMath? This is not SageMath coding, it's actually Python coding, Python programming coding. Suppose that y to be, suppose we call, okay, not y, so let us define a function. Instead of that, let's define a leap year function. Leap year check, that's the function name. It will check if y is a leap year or not. How do you check that? If y is a multiple of 400, how do we check multiple of 400? Dividing with 400, the remainder is 0. Then we will say true, answer is true. Okay, what otherwise? Else, elif, y percentage 100 not equal to 0, it's not a multiple of 100, and y is a multiple of 4. Then what do we say? Then also we will say that it's true, it's a leap year. And what if these two conditions are not met? It's not a leap year. True is capital T, false is capital F. I think small f and small true also will work, but let us stick to this. Now we have defined a function. Okay, we have defined a function. What next? Let us ask. What should we ask? Y equal to say 1900. Y, okay, why leap year? That's a question. We are putting a question mark, and we are feeding that leap year y to this. So what will happen now? Y will be taken as 1900. Here 1900 will be printed. Question mark leap year question mark also will be printed. After that, the y will be fed back to these lines. So it will verify if y percentage 400 is 0 or not. Is y percentage 04? That is y remainder with 400 0? No. Therefore, this will not happen. We will check again if it is not a multiple of 100 and a multiple of 4, but this is a multiple of 100. Then this will not also. This also will not work. Therefore, the final thing will work. What is the final thing? False will be returned. So the answer will be printed as false. Let us see.
Please check elif condition. Elif condition. Double equal.
That's okay. Elif is fine. What's the problem there? Invalid syntax is an AND. Okay, let us try with AND. Will it work? Name leap year is not defined. Leap year check is the name that we are using. Okay, sorry. Leap year check. Okay, and instead of double and, probably I am supposed to use A and D. Okay, I am getting confused sometimes with Python construction and what you call C construction, because in C this double and is used for and here it is A and D and, I guess. Or I don't know whether this double and also will work. That's not working. This double and is not the construct and. That's the word we have to use. The question is 1900. Maybe we can even put is. Is 1900 a leap year? False. What next? Is 2000 a leap year? True. What next? Is 2020 a leap year? True. Is 2022 a leap year? False. I am copying and pasting the entire thing to the Google Sheet. You will try. Okay, now let us try to print all the leap years in the range. Suppose that from where to where? Suppose that we try to print all the leap years from 1900 to 2022. Let us try to do that, but using a for loop. Okay, we are going to use a for loop. For y in range, which range? 1900 to 2022, but you need to use 2023 because you know that when you use the range, the problem is that range will actually give you a left close, right open interval. So 2023, 2022 will not be included. So we need to put 2023 there. If you want to include 2022 also. So this is a simple thing. we will use if also. If leap year check, because you will get either true or false. If this is true, then what will you do? You will simply print y. Maybe you can is a leap year. So we are looping over all the years from 1900 to 2022, and we are checking if it's a leap year or not. If the answer from the leap year function is true, we will print that to be a leap year. That's it. Okay. Is there an extra bracket? Y in range, maybe this is not required. Yeah, this bracket is not required. So the answer is 1904 is a leap year. So you can see that. See, inside this 4, I am giving 4 spaces, 1, 2, 3, 4. Inside this if, again I am giving 1, 2, 3, 4, because whatever I want to keep inside this if condition, I need to give 4 spaces here, right? If you are trying inside the SageMath system, automatically that spacing will be given. But the next thing is that if you want, see, you are going to print the list of leap years after verifying all these years, right? Therefore, you are going to print it outside the for loop after verifying all these years. So you need to, you should not put it here. See, if you put it here, what will happen is that it's a part of the if construct. That's not. If you put it here, it's a part of the for construct. That is also not, because we don't want to print each and every year in each and every after testing each and every year. We do not want a printout. We want a printout only towards the end. So keep it towards the left margin. Now try. Appen, spelling mistake, APPET. Exactly the same thing, but now as a list. So we used something called a for loop. I am updating the Google document. I have updated the Google document. You may please try. So I hope that this concept is very clear to all of you using this for loop, because using for loop and if conditions are very much essential for doing mathematics problems. Without that, we cannot simply proceed. We need that. Now you can find out non-leap years also easily now, because once you have found out the list of all leap years, now you need to just take the difference. Okay, set theoretical difference is more than enough. You don't have to do it again and again. So non-leap years, to find that. So what you can do is take the set of all leap years, and subtract list range 1900, 2023, We are taking the list of that. Too many things here. Where are the non-leap years? Yeah, it's here. These are non-leap years. So what I did is, I just constructed a set out of the numbers from 1900 to 2022. From that, the leap year, whatever we have calculated, whatever we have decided the years to be leap years, that set is now subtracted. Therefore, you will get non-leap years in the range 1900 to 2023. The Google document is once again updated. So in fact, use this for loop I'm just trying to explain how to use for loop properly. So many of the things that I'm explaining, many of the ideas that I'm explaining using this for loop, if conditions, etc., can be directly done in SageMath without using any of these loops. But why I am saying these things is that we must be familiar with how to use these for loops for understanding difficult concepts later. So for simple examples are good enough for understanding the basic concepts, like how to use for loops. Let us try to find out the list of all primes in the range 1 to 100, say, using for, if, etc. So that's the example. Next example, we are trying to find primes. But remember that SageMath has built-in functionalities for locating primes. I am not explaining this the next problem, next code to tell you how to find primes in SageMath, but on the other hand, I am explaining this to make you understand that how to use for, if loops in SageMath effectively. Okay, that's it. One to 100. So there are different ways for finding primes in the range 1 to 100. The very first thing is that, so what should we do? The sieve of Eratosthenes probably we can use. The sieve of Eratosthenes, the technique is that, so initially we start listing all the numbers 1 to 100, not 1 to 100, 1 is not required, 2 to 100. The first number, because it's not a multiple of any other number before that, other than 1, the first number we mark it as a prime. After that, what do we do is we will remove all the multiples of 2 from the list of numbers that we have already taken. That means 2 to not 2 to 100, 3 to 100. All the multiples of 2 are removed from 3 to 100. Okay. So what is left now without being removed? What is the first number that is being left without being removed? That's 3. So we will mark 3 as a prime number. So 2 and 3 are prime numbers. After that, we will see that what is the next number. Sorry, all the multiples of 3 are now removed from the list. This way we will proceed. Okay, so two things are involved here. The one thing is that marking a number as prime and pushing it to one prime list. Second thing is that once you marked a number as a prime, remove that from the previous list, the original list. Not only that, remove all the multiples of a number also from that original list. Okay, so CO of Pareto's things. If you are interested in knowing exactly what I'm talking about, maybe you can do a Google search also to see what CO of Pareto's things is. We are going to do that using SageMath. So if you want to know exactly what we are trying to do, maybe you can search this Wikipedia link later. That's about CO of Pareto's things. Yeah, here is the Wikipedia link for you to see. Okay, CO of Pareto's things, we are trying to do that using SageMath. So first 100, not first 100, first 100 in the sense that 2 to 100, 2 to 100. See, I have not used 2, 3, etc. because if I do not list the first two numbers, automatically the difference between the consecutive numbers will be taken as 1. So if you want the difference to be something other than 1, you need to specifically say what exactly the difference is. So first 100, it is actually not first 100, it is nothing but 2 to 100. Prime list, initially it's empty, it's an empty list. So what is the technique that we told? So since 2 was not taken out, 2 is a prime. So take 2 out and push it to prime list. Prime form is okay, there is a command called pop. Let us see what exactly the effect of this pop is. Print first 100, print so the first 100 is after popping the 0th element, which is 2. The original first 100 became 3 to up to this, and prime found became this element. Okay, so popping simply means that taking up. So popping simply means that take the 0th element out and push it to this prime found. Okay, here what happens is the 0th element is taken out of this first 100 and pushed it to prime found. But instead of that, we can even take primes found, append. This is also possible. So we'll be doing exactly the same thing every time. So or primes list. So 2 is the first. Now what next? We need to remove all the multiples of 2 from first 100. 4, n in first 100 if n percentage. So percentage of what we are supposed to take? Percentage of 2 we are supposed to take, but 2 is nothing but the last prime that we added. So the last prime we take it like this: prime list last one. Last one, how do we count that? Length of prime list. Length of prime list is now 1, therefore we need the 0th element, therefore length of prime list minus 1 equal to 0. So what do we do? So what we did, we took the remainder n percentage 2, but 2 is what? 2 is now the last element in the prime list, because there is only one element in that prime list. Last element means the 0th element. So 0th element is what? 0th element is the length of the prime list is now 1. So 0th element is length of prime list minus 1. That's why we give it here. Now if we append one more element, there will be 2 and 3. Therefore the length of the prime list will be 2. Therefore length of prime list minus 1 will be 1. So 1th element, which is 3. We will take 3 and try to divide every number with that. So if the remainder is 0, what we will do is we will remove. Okay, we will remove. Remove n. We will see after 2 steps what exactly is going on. Now what is left now? In the beginning, that will be taken as a prime. Whatever is left now in the beginning will be taken as a prime. So again, same process. And let us see what the output is. Sorry, prime list, where is that? So the original list became, see what are the things that we have done? We have removed all multiples of 2 in the beginning. All multiples of 2 have been removed, therefore 3, 5, etc. will be remaining. Now the first element remaining in that first 100, which is 3, that is taken out of first 100 and appended to prime list. Therefore prime list became 2, 3. Now if we continue this process, what will happen? Let us continue this process without changing the code. Same code and see what's happening. It's 2, 3, 5. Let us continue this once again. So how many times you will continue this? As long as first 100 consists of any element. So we will loop unless this first 100, the length of first 100 is 0. So maybe instead of doing all these things, we can do all these things inside a loop. Maybe we can do all these things inside a loop. Okay, I will tell you how to do that, how to do all these things inside a loop. But before that, let me copy and paste this code to the Google Sheet, Google document. So sieve of variety of stains is now updated to the Google document. Okay. The feedback link I will copy and paste to the Google YouTube streaming also, which was broken in between, I guess. Okay, so if you are comfortable with what we have done, I will show you how to do all these things inside the loop. Instead of copying and pasting the same code again and again, we will create one more for loop, 2 for loops. It is not actually 2 for loops. So how long we are going to continue this removing removing multiples, appending the removing the first element and appending it to the prime list. How long we will continue? As long as the list first 100 consists of at least one element. As long as it becomes the length of that becomes non-zero, we will continue this process. Therefore, instead of doing all these things, what we are going to do is we are going to do something like this. After creating the first element, what we will do is, after appending 1, what we are going to do is this. While length of first 100 is greater than 0, we are going to continue this process. Now, only this much is enough. No need to do all these things. So what will happen here? Now in the initial stage, see that first 100 consists of how many numbers? 1 and 2 are already removed, so 98 numbers. Therefore the length is 98, it's greater than 0. So this process will continue. So after that multiples of 100 are removed. After that multiples of 2 are removed. Then the first number remaining is 3. Still first 100 has some elements, therefore that's also kept. But I should not have done that. But instead of that, I would have copied and pasted this thing, right? So that I can share this thing with you. I'm just copying and pasting this much. Let us see. See this, all the primes up to 100, the first 100 is now completely empty. Only these many chords. So we located all the primes in this list. If you do not want the prime list in between, what you can do is that you can simply push this prime list to outside this while loop, so that only once this will be printed. These two you can suppress if you want and move it outside the while loop, so only this will be printed. And this is also not necessary. This is also not necessary. That's it. All primes up to 100. See of various things implemented using SageMath, Python, whatever. It's actually Python only. There is no SageMath involved in this. But I used it only for demonstrating how this while loop is used. How see that the for loop is inside the while loop. Therefore, I have pushed it to some space from the left margin. Here also that pushing is happening. Here also, right? You can see that pushing happening here. Updating the Google document with this. No, there is an alternate way, of course. The alternate way is to find out if there are any divisors of a number. So to check if a number is a prime or not, the alternate way is again to use a loop and find out if it has any divisor or not up to that particular number. If it has a divisor, then you can decide that it is not a prime. If it has no divisors, then you can decide that it's a prime. So that can also be done using the loop, but since our aim is not to devise techniques for understanding, techniques for finding out primes and all, we are not interested in, because already there are built-in commands available in SageMath for determining if a number is a prime or not. So this particular example is introduced basically to understand how to use while loop, how to use for loop, how to use this append, how to use remove, how to use pop, all these things effectively. Okay. This for loop can actually be used for finding out norm of a vector, provided that the vector is given as a tuple. Suppose that, so how do we find a norm of a vector? Norm of vector is usually found using sigma xi square. If xi's are the component vectors, it's found as sigma xi square. Okay. So for finding the unit vector, we are supposed to divide a vector with that norm. Then we can find the angle also using cos inverse. We can try to find that properly. So finding out norm of a vector and handling the components. So suppose that vector is V, and V is nothing but 1, 2, 3, 4, 5, 7, something like that. So how do we find the norm of this? So we know that the components are 1, 2, 3, 5, 7. So we need to loop through all these components and we need to square. That's what we are supposed to do. Norm of V is nothing but, so this is quite straight away. You don't have to even use the for loop. This is the good thing about handling lists in Python as well as SageMath. So what you are supposed to do is, you are supposed to take all squares first of all. So what are the squares? V I square for I in range. So we need to find out the length of V, right? I in range, length of V. This is more than enough. You don't have to specify 0 to etc. Length of V, that's it. So let us see, and then you need to sum it. You need to sum it, and not only that, you need to take the square root. So let us see what's the numbers. Maybe initially we can try with a small one. Square root of 5. See, the good thing about SageMath is that whatever function is available in SageMath, you can use it inside a list, and you can quickly manipulate the list so that the components also you can handle. You can do whatever you like on the components, so that the final result will be coming out. So if you are doing all these things in C programming or any other software, what you have to do is that you may have to handle the individual components individually. Okay, you cannot directly handle all these things like this. This is how we find the norm. Now, if you know this is norm, and what about dot product? So how do you find angle between two vectors given? Suppose that two vectors are given. Suppose that we are given two vectors. Or let me just update this. we need to find something called dot product, right? So suppose that we are given vector u equal to as a tuple, let us take 1 2 and v equal to 3 4. We know that we need to find out the angle between the two vectors. That's what our aim is. So for that, let us define the norm to be a function. Define norm v. Return this number. Let us define it as a function. I am not defining norm v simply because already there will be a function called norm inside SageMath. If you are defining your own function using the same function name available in SageMath, what will happen is that the SageMath function will not be available to you in that worksheet. If you define your own function with the SageMath function name, the SageMath function name will vanish and your function will work. Your function will have the highest priority. So if you are confused, you should put some extra symbols to that function name. That's better. So the angle is theta. That's the angle. How do we find that? Angle is equal to a dot b by norm a, norm b, cos inverse, right? Okay, so a dot b we need to define. So how do we define a dot b? Diff dot product. Let us define a b. How do we do that? A b. So that's quite simple. So these two are vectors. So what are we supposed to do? Assuming that the lengths of these two vectors are compatible, they are the same. Sum ai star bi for I in range length of A. Length of A and B, we are assuming that to be the same. The sum of this, that's A dot B. So theta is nothing but cosine, cos inverse of dot product uv divided by norm vu star, oh sorry, norm, that spelling is wrong. So if you want numerical approximation, it's here in radians. What happened? Have we used anywhere? What happened to this? 11 square root. So what's the problem with that? N of not defined. Why is it like that? Okay, what is this value? Let's see. Square root 5. There is something wrong. What is that? Dot product. So what is wrong here? 11 square root 5 is it's a large value. It should be actually norm of A. Have I taken the square root? So this is dot product UV. Okay, let us try to see it one by one to rectify, to identify what exactly the error is. Is it correct? Dot product of U and V. So dot product of U and V must be 1, 3, 2, 4. So 3 plus 8, it's 11. 11, correct. That's correct. Now norm of norm V of U. Norm V of U must be 1 square plus 2 square, the square root. 1 square plus 2 square, the square root is a square root 5. That's correct.
I think that one extra bracket squared in the denominator.
Is there an extra bracket somewhere? Dot product.
Term of U and third term of the there. Because
maybe okay. I forgot to put a bracket extra. I think because this norm V and no, it's divided with norm V, but not divided with norm V. Sorry, the division with norm V, division with norm U happened, but division with norm V did not happen. One bracket was missing. See, I should have put this entire thing inside the bracket. Okay. Then only it will come to the denominator. Otherwise, one thing is in the denominator and the other thing is not in the denominator. Now, one more. Now it should be correct. Hey, what is this? Norm V. Norm V. Okay, this is correct. A dot B, U dot V by norm U, norm V. Oh, theta, I have not made it into theta, right? Okay. Here also it's missing. Here that bracket is missing. Yeah, that's correct. That's it. So the norm function, let me update the Google document with all this. Update it, copy it and paste it. Yeah, we'll probably stop today's session. If there is any question, you may please ask now, or otherwise we will be continuing with. So what were the topics that we had for today? Discussing sets, accessing elements in such data, indentation issues, variation, etc. Okay, right. So tomorrow we will be continuing with certain things related to plotting. Okay, if there is anything related to today's topics that we have discussed, you may please ask. I have already updated the entire Google Sheet, and as I promised yesterday, I will be uploading the worksheets that I have prepared yesterday and today itself to the Google Drive, and I will share the link with you so that you can download and try yourself. Thank you.
I have attended your previous Python this workshop. Now I was attending this workshop. I can see that that in the Python language and this SageMath is very common thing is there, that most of the command is particularly same as before. So what are the difference between the SageMath command and that Python command?
Okay, basically what what I should say is that whatever Python program that you can type inside a Python terminal will virtually run inside this SageMath terminal. Okay, whatever Python command you are trying, because it's a Python 3 related, that will run inside the Sage terminal, because Sage is written using Python, and almost all the Python commands are acceptable to Sage as well. But SageMath has more and more libraries compared to Python. And not only that, many of the existing difficulties in SageMath in dealing with mathematics, there are certain easy ways in SageMath, easy techniques in SageMath available for doing mathematics problems. So SageMath is a Python programming language made much more suitable and easy for mathematicians. That's it. And not only that, the SageMath has used the syntax of Python programming language, but it has included inside that many other software, programming software. But this software is not available in Python. But using the Python structure, you can use these programs standing inside the SageMath framework.
Okay, sir.
Okay, thank you. Thank you.
Good evening, sir.
Good evening.
I have a question. It's actually not related to this session. Sir, yesterday I missed the initial part, so I could not see the installation process of SageMath. And in fact, I have actually tried installing this software earlier, and I have faced difficulties. So, difficulty as in when I try to run it using Jupyter Notebook, I cannot proceed. The material is not saving, and it's not running as well. I have installed Sage 9.3. So I don't know why this problem is occurring. So can you just show me the installation process in short, and how to use this Jupyter Notebook using SageMath?
So are you using a Windows machine?
Yes, sir.
So what exactly is the error happening? Are you able to get a SageMath icon on the desktop?
Yes, sir. I'm getting the SageMath icon as well as I'm able to open it.
Okay.
But the problem is when I try to run in the cell, it's not running, and it and in one corner it's showing error. It's showing that the whole thing is not saved, and it's not giving me the output as well.
Okay, the whole thing is not saved essentially means that there are certain permission issues, it seems. So can you please send me the screenshot of what exactly is happening so that I can try to answer.
Sure.
You may please email the screenshot to me, and I don't know that email address is shared with you. If it is not shared, I will just type it now here. Please send me the screenshot to this email address.
Sure, sir.
I can just try and see what exactly is happening there, because certain permission issues usually creates issues with Windows, especially with Windows 10, maybe Windows 11, Windows 11 or Windows 12. I don't know what exactly is the current version. I think Windows 10 onwards there were certain issues, and that's why the SageMath, what they have done is that they are now suggesting that you run an Ubuntu, a minimal version inside the Windows itself, inside which you run SageMath. I will probably try to explain that also in tomorrow's lecture, that how to run SageMath inside Ubuntu, inside Windows. Okay, if this is not succeeding, I will try to explain that also once again tomorrow. So that will be useful for many using Windows machine. Okay, you just send me the screenshot first of all. I will try to see that.
Thanks a lot.
Okay, thank you. Okay, if there is nothing else, we will stop today's session. We will conclude today's session, and we will probably meet at the same time tomorrow. Is that okay, sir? Anil, sir?
Okay, sir. Okay, sir. Thank you. Thank you, sir.
Okay. Okay. Thank you very much. Okay. Good night.